No problem, sir. I will go to that. So, hello students. Hello students, very good evening to all. So, sir name is Nagaraju, he is a gate ranker and he will take the class for the semiconductor devices. So, you can support him. So, sir will take the semiconductor devices, that is last chapter, which are the two chapters. One is the FET and other one is the MOSFET. In that there is a input output characteristics and working construction and all the details. Sir will take over it. Please. It is already here.
Hi students, today our topic is FET and MOSFET. FET is nothing but field effect transistor, and MOSFET is nothing but metal oxide semiconductor FET. So I will go with first FET. So FET is called field effect transistor. So why it is called field effect transistor? Because of this the field effect, FET current is flowing. Because of this field effect, FET current is flowing. So FET is a three-terminal semiconductor device. FET is a three-terminal semiconductor device. The three terminals are gate, drain and source. The three terminals are called gate, drain, source. Gate and source are called input terminals and drain and source are called output terminals. This is called VDS and this is VGS. Okay. So basically FET is working in depletion mode. FET is working in depletion mode. This depletion mode are two types. One is N channel depletion mode and other one is P channel depletion mode. Okay. This is all about the introduction of the FET. So FET is a three-terminal semiconductor devices and the three terminals are gate, drain, source. FET is working under depletion mode. That the depletion modes are two types, N channel and P channel. Now we will see the basic construction of FET. and what are the input and output characteristics of the FET, and what are the parameters related to the FET. Okay. First of all, we will go to the construction of FET. Sorry. Construction of FET. I already told now see, this is the construction of FET. I have gate, drain, source. There are two types of FETs I already told. One is N channel and the other one is P channel FET. Is that right? This is the N channel FET, this is the P channel FET. Okay. First we will discuss N channel FET, after we will discuss P channel FET. So how the N channel FET will work when I apply the input voltage drain and source and gate and source. How the P channel will work when I apply the voltage between gate and drain and source and gate and source we will discuss. Okay, one by one we will discuss. So this is the VGS is nothing but input voltage applied between gate and source. This is the output voltage applied between drain and source. So different voltages, I am taking the different voltages of VGS and VDS. Now how N channel FET will work, we will see. Okay. First I am making VGS equal to 0. And VDS equal to 0. So I am taking VGS equal 0, VDS equal to 0. So when VGS equals 0, it will get, this open circuited, and VDS also there is a open circuited. It means no voltage, this nothing but, then ID becomes 0, because there are no voltages, VGS and VDS no. So that ID become 0. So first point is VGS 0, VDS 0, ID equal to 0. Okay. Okay. The second condition is VGS 0, VDS positive. I am making VGS equal to 0, VDS is positive. It means whenever VDS is positive, so here electrons will flow. Whenever voltage increases, electrons will flow through the drain terminal. So this is, here no voltage is there, here some voltage is applied, so that the electrons flow like this. So there is a formation of current I, nothing but drain to source current. So when I applied the VDS is positive, drain to source current will flow. So when VDS is positive, ID is positive. Okay, na? Okay, we will come. Okay. Okay. So I have two conditions. One is VGS equal to 0, VDS equal to 0. I am getting ID equal to 0 because of, now see, I am explaining how this current become 0. Here internally in FET two diodes are there. One is this is the P layer, this is the N layer, one diode will form. The other one is one P diode, one N diode, there is another PN junction. So when VGS equal to 0, VDS equal to 0, these two diodes are get open circuited so that no current will flow through the drain to source. Now when I am applying the VDS is positive, then two junction become forward biased and current will flow. So this is the condition. Okay. Now see, third condition was VGS is negative, VDS keeping positive. When VGS become negative and VDS is positive, that was the third condition. Okay, na? Now see. Now applied, VGS is negative na, so this is negative and this is positive. So this is the drain terminal, this is the drain terminal, and this is the source terminal, this is the positive and this is negative. This is the source. So okay. So due to the negative charge, negative field on the gate terminal, whatever this is layer is called depletion layer. This is called depletion layer. So whenever gate is negative na, so depletion layer will increase gradually. This is the depletion layer. So by seeing this depletion layer, the width of the channel is decreasing na. This is the N channel, so width of the channel is decreasing. So this channel is get decreasing. So whenever the channel is decreasing na, so whenever N channel is decreasing, resistance increases, so that current will decreases, because we know that Ohm's law V equal to IR, so I equal to V by R. So whenever R increases na, so current will decreases. So in third condition, current will decreases. Okay na? When VGS is negative and VDS is positive, so current will decreases. So in next condition, I keep increasing negative voltage of gate. So these two layers, after some time they will meet at one point. This point is called pinch off point, and that voltage is called pinch off voltage. This voltage is called pinch off voltage. This is called pinch off voltage. So what is meant by pinch off voltage? What is meant by pinch off voltage? It is the minimum, this is the very important definition for exam, pinch off voltage. It is the minimum voltage, of VDS to require, it is the minimum voltage of VDS to require to make drain current is constant. It means whenever I applied the pinch off voltage, the drain current becomes constant. Okay na? So we will go to the characteristics of FET. So we will see the FET characteristics. Now see. This is called breakdown region. Okay na? Now see. So this is characteristics called drain characteristics or output characteristics. Okay na? So the drain characteristics are drawn between ID versus VDS. I am applying different types of VGS voltages. First I taken VGS equal to 0, then VGS equal to -1, VGS equal to -2 and VGS equal to -3 I taken. Okay, so this region is called, in JFET I have 3 regions in drain characteristics. One is ohmic region, one is pinch off region, one is breakdown region. So in ohmic region, now see the current is passing through the origin in linear. Now see ohmic region. So in ohmic region, when current is linear, okay, in ohmic region, so current is linear in ohmic region, so ohmic region will follows the Ohm's law. Ohmic region will follows the Ohm's law, because we know that Ohm's law equal to V equal to IR, so V is directly proportional to I. So whenever VDS increasing na, so the current will linearly increases, up to the pinch off point. So after the pinch off point, now see the drain current becomes constant. The drain current becomes constant. So this region is called pinch off region or constant current region. Okay na? Actually FETs are used in amplifiers. So in this region actually amplification takes place. So this is called breakdown region. Here see, whenever I keep increasing VDS to more value, at one point of time breakdown takes place. So whenever breakdown takes place, current will increase enormously. Okay na? So this characteristics called drain characteristics of JFET. So we will go to the another characteristics called transfer characteristics. This characteristics called drain characteristics or output characteristics, and one more characteristics are there, that's called transfer characteristics. Transfer characteristics. So this is ID, this is VGS. Okay na? So this is negative relaxation na? So I am taking the negative values -1, -2, -3, -4. So this called ID and this is called IDSS. This VGS equal to 0. So when VGS equal to 0, there is a current called IDSS. This is IDSS is called drain current when VGS off. It means VGS equal to 0. Now see, the drain current is keeps decreasing whenever VGS increasing in a negative way. Now see, at the -1 I have drain current here, at -2 drain current here, at -3 drain current here. It means whenever VGS is negative and keep increasing, ID will decrease. This is called nothing but whenever ID current decreases, that mode is called depletion mode. Before starting the lecture, I already told FET work in depletion mode. Why depletion mode means? This is the answer. Whenever VGS increases with the negative voltage, so ID decreases. So depletion mode is nothing but whenever ID decreases, that mode is called depletion mode. That mode is called depletion mode. Okay, na? So this is the FET characteristics. There are some parameters, they will ask like one question, find ID, find drain current, IDSS they will give like 3 ampere, VGS they will give 1 minus VGS by VGS off. So VGS is 3 volts. So VGS off equal to some 4 volts will give it. Okay, now find drain current. They have given parameters IDSS and VGS, VGF. The formula is drain current equal to IDSS into 1 minus VGS by VGS off. Okay, na? This is the formula. So substitute all the values. 3, 1 minus VGS 3 by 4. Okay. So 3 into 4 minus 3, it means 1 by 4, nothing but 3 by 4. 3 by 4 means 0.75. What I am finding? Current. So ampere. Okay, na? This is the problem, possibility for problem they will ask in the examination of JFET. Okay. Now I will go to some parameters related to the JFET. First parameter is drain resistance. First parameter is drain resistance. So drain resistance is indicated with RD. RD range is 10 power 8 ohm. Okay, the range is RD is 10 power 8 ohm. So what is the RD formula? RD equal to delta VDS by delta ID when VGS equal to constant. Okay, so what is the definition of drain resistance? It is the change of drain to source voltage to the change in drain current, nothing but drain resistance. One more parameter, transconductance. So transconductance. So transconductance is indicated with GM. So the formula for GM is delta ID by delta VGS when VDS equal to constant. Okay, this is the transconductor formula. The change in drain current by change in gate to source voltage. Okay, so problem change in conductance. Okay, one more parameter is there, that is called amplification factor. So amplification factor. So mu equal to Gm into RD. Okay. So amplification factor mu equal to Gm into RD. Okay. We will discuss one problem on this. Okay. Now see. Delta ID. We just okay. So problem is delta VDS equal to some 10 power 8 okay, some 10 power VDS equal to, suppose there is 10 square, it means 100 volts you have given. Okay. Next, drain current is, change in drain current is, they will give like 10 power minus 6 ampere, nothing but micro ampere. Okay na? So micro means 10 power minus 6. Okay. Next they will give VGS. Okay. So delta VGS equal to, they will give like delta ID 10 power minus 6 na, like VDS less than VGS is negative. So taking some parameter 10 power minus 6 because transconductance 10 power minus 8. Okay, 10 power minus 6. Here I will take some 10 power minus 6. So Gm na. So 1 is conductance Gm equal to transconductance. Conductance is nothing but by V. It means nothing but admittance. It means conductance means mho. So mho means delta I 10 power minus 6. This I will give 10 power minus 2. Okay. So, see. So delta VGS equal to 10 power minus 2, volts. So find RD. So RD equal to delta VDS by ID. So what is the delta VDS? 100 by delta ID 1 into 10 power minus 6 ampere. It means 10 power minus 6. It go to the numerator, it will become 10 power 8. Ohm. Now RD, Gm. So what is the transconductance? So transconductance formula is delta ID. So what is the delta ID? So 1 into 10 power minus 6 by delta VGS 10 power minus 2. So 10 power 2 equal to 10 power minus 6 into 10 power 2. We will get 10 power minus 4 mho. So conductance units are mho and resistance units are ohm. Okay na? Next, amplification factor. So what is the amplification factor? Gm into RD. So what is the Gm? I have find out 10 power minus 4 and 10 power 8. So amplification factor is 10 power 8 into 10 power minus 4. So I will get 10 power 4. Okay na? I will get 10 power 4. No units. This is a factor na. So factor doesn't have any units. Okay. Okay. So now see, so what is the difference between okay, so advantage of FET compared to BJT. So what are the advantages of FET compared to BJT? So BJT, what is the full form of BJT? Bipolar junction transistor. bipolar junction transistor. So bipolar junction transistor, BJT full form is bipolar junction transistor. Now we will see, here current in the BJT, so current in the BJT, this is the bipolar, na? It means two polarities should be there, okay na? Electrons and holes. It means current in the BJT due to the both electrons and holes, okay na? That's why called both electrons and holes are there, na? That is why called BJT is a bipolar device. This is a very, very, very important, okay na? So bipolar device. So why BJT is named as a bipolar device? The current in the BJT due to the both electrons and holes. That's why called BJT is a bipolar device. Now see FET. In FET, current is due to only one type of charge carrier. Only one type of charge carrier. So either electrons or holes, okay na? So either electrons or holes. Due to this either electrons or holes, only current is flowing. That's why called this is a unipolar device, okay na? It's a unipolar device, okay na? So now you understand na what is the clearly difference between the BJT and FET. So I am reviewing this. I am just write down the point. So first point is FET is a unipolar here. First point is BJT is a bipolar, okay na? So directly I am writing the advantages compared to the BJT, okay? So input resistance of FET is more. Input resistance of FET is more compared to BJT. So third point is FET is less noisy, compared to BJT. That's why due to this less noisy, FETs are mostly using in communication purpose, okay na? Communication purpose we are using FET. The fourth one is FET is easily fabricated IC chip. Compared to BJT, okay? So thermal stability of FET is more compared to BJT, okay na? So sixth point is high power gain. FET has high power gain, okay? So these are the advantages of FET when compared to the BJT. see. Okay, applications of FETs. So, application of FET. So, first application is because of high input impedance, FETs are using in FETs are using in buffer circuits. You know, because of high input impedance, FETs are using in buffer circuit. To make ICs means integrated chips. We are widely using, you know, FET. FETs are using because of less space occupied. I already told, due to less noisy, FETs are used in communication purpose. Nothing but radio receivers and TV receivers. Okay. So the fourth point is analog watches. In analog watches also we are using the FETs. And the fifth point is FETs are used in electrostatic voltmeter. Due to high input impedance. Okay, na? So sixth one is in cascode connection also. You know, we are using the FETs. Okay, na? So these are the different types of applications we are using the, you know, FET. Okay. After 10 minutes, you know, we will discuss about MOSFET construction and working principle of MOSFET, and what are the characteristics of the MOSFET, and what is the difference between FET and you know, MOSFET. Okay. After 10 minutes, we will continue. Thank you.
The source and drain terminal are connected through metallic contacts. You can see these are metallic contacts. These contacts are called as metallic contacts. This one as well, also this one are the metallic contact. And these metallic contacts are connected to N channel. The gate is also connected to metallic contact, but it is insulated. As you can see, it is insulated. SiO2 is the insulator. Insulator is SiO2. The name metal oxide semiconductor FET because for gate, drain and source the metals are connected. Oxide is for silicon dioxide, insulator. Semiconductor for basic structure on which N-type and P-type are diffused. Since the gate and channel are insulated, it is also called as insulated gate FET. Now we'll see the enhancement type of MOSFET. The basic construction of N-channel enhancement type of MOSFET is shown in this figure. A slab of P-type material is formed from the silicon base and this is referred as the substrate. The substrate is internally connected to source, but the channel is absent in the doping region. This is the doping region. This is the only difference between the depletion type and enhancement type of MOSFET. In the next lecture, you will see the is that there will be no channel present in an MOSFET, and we understood that the operation of MOSFET as well as there will be no channel present in an enhancement type of MOSFET, and in an voltage between gate and source voltage. We know source and we can make a connection. We'll apply positive voltage between drain and source. Positive voltage. This voltage we can call this as VDS, which is positive and negative like this. And let us apply voltage between source, gate and source. We'll make it 0. So this voltage is VGS ground. Now we have made the connection where we have taken VGS is in N channel will move towards drain. So the electrons which are present here in N channel, it will move towards drain. This will constitute electric current in the opposite direction of flow of electrons. So the current will flow in this direction through drain, through this channel, and it will go through the source terminal. So we can call the current as ID, as drain current, and source current as IS. As we keep on increasing VDS, as we increase VDS, drain current will also increase. And since we are having two regions, N region and P region here, definitely there will be a depletion region in between these two regions. And depletion region will also increase. And at some point of voltage VDS, the depletion region will be such a level.
ఉంది సార్, ఇంకా ఇంకొక 15 minutes 20 minutes ఉంది.
సౌండ్ డబుల్ వస్తుంది. వేరే వస్తుంది.
అరే అంటే ఫోన్ది ఓపెన్ చేసిన అనుకుంటా.
ఇక్కడ మైక్ ఉంటుంది కదా సార్, దిస్ మైక్ ఈస్
So, the next topic is MOSFET. MOSFET is metal oxide semiconductor field effect transistor. Okay. So, MOSFET is metal oxide semiconductor field effect transistor. Why it is so called metal oxide semiconductor? Okay. I will discuss this term when I drawing the MOSFET construction, how it is named called metal oxide semiconductor, you know. So, basically MOSFET working in two modes. One is depletion mode, second one is enhancement mode. So, what is the difference between depletion mode, enhancement mode? So, first of all, depletion mode are two types. One is N channel, the other one is P channel. So, enhancements are also N channel, the other one is P channel. Okay, na? So, N channel, P channel, and in enhancement mode also N channel, P channel, where FET is working only in depletion mode only. Okay, na? This comparison is very, very important. MOSFET works in two modes, that is called depletion mode and enhancement mode. FET is working only in depletion mode. Okay, so this point you have to remember, and so N channel, P channel, enhancement, and depletion mode. Okay. Okay. So first one is depletion mode. Depletion mode are N channel, the other one is P channel. So the N channel diagram is, depletion mode diagram is like this. This is the N channel and this is the P channel. Okay. This is the P channel. Now enhancement mode. This is the N channel, the other one is the P channel. Sorry. These are the basic diagrams, of depletion mode and enhanced mode, both N channel, P channel. Okay, these diagrams are very, very important for your, examination. Now we will see the what is the, construction and working principle of depletion MOSFET and enhancement MOSFET. Okay. D-MOSFET, is the E-MOSFET. Now see the diagram of D-MOSFET. This is the N. Like this. These are the metallic contacts. These are the metallic contacts. This is the gate, this is the drain, and this is the source terminal. And internally, substrate is, P substrate is connected to the source. Internally, P substrate is connected to the S, it means source. So these are the metallic contacts, and this is the acts as dielectric medium SiO2. Due to the silicon lab, P substrate is formed. This is the PN junction diode, so P substrate is formed due to the silicon. Now we will see the E-MOSFET. So you need to observe the major difference between D-MOSFET and E-MOSFET. This is a P substrate, okay. This is the SiO2, sorry. P substrate is internally connected to the source, and this is ground, and this is ground. Now see major difference between, this is nothing but channel, this is channel. Here N channel is absent, here channel is absent. These are the doping regions, these are the doping region, okay na? These also doping regions. Basically this drain and source are acts as a electrodes. So to differentiate these electrodes we need some dielectric medium, that is nothing but SiO2, silicon dioxide. Now see MOSFET full form is metal oxide semiconductor field effect transistor. MOSFET full form is, now see MOSFET full form is metal oxide semiconductor field effect transistor. Now see how the name is called, metals. Now in D-MOSFET I am using some metallic contacts, nothing but these metallic contacts are made with metals. So metal. Next, oxide. I am using some medium, nothing but dielectric medium that is made with some oxide. So oxide. So semiconductors. So these N-type, P-type is there na. So these forms the one PN junction that is made with the semiconductor, silicon or germanium. So this is called metal oxide semiconductor field effect transistor. Okay na? So okay, we will discuss one by one. D-MOSFET after after that E-MOSFET we will discuss. Okay. Okay. Now see, now D-MOSFET, working of D-MOSFET. So working of D-MOSFET. See, this is channel N, na? Yes. Okay. Okay. This is gate and this is source. Okay, this is P substrate. This is the drain, na? This is the drain. So now I am applying some voltage to the drain, nothing but VDS, and now see. Okay, drain to source, na? Okay. In gate also I am applying some voltage. Now I am applying different types of voltages. Now see, I am applying VGS equal to 0. I am applying VGS equal to 0 and VDS equal to positive. Now see, VDS is positive, VGS 0. It means it get short circuited. VGS equal to 0. So whenever VGS equal to 0, this positive na, this is positive, this is negative terminal, this positive, so drain having some positive charge na. So in N channel there are some electrons. In N channel there are some electrons. We know that opposite charges are get attracted and same charges are repels each other. Now see, this is the positive charge, this is the negative charge. So these two gets attracted. So current flowing through, like this. Go to the source terminal. This is the ID current, drain current will flow like this. Okay na? So current is always flows opposite to the electron movement. Electron going like this and current is coming like this. Okay na? So whenever VGS equal to 0, VDS is positive, so IDS will increase. Okay na? IDS will increase. Second condition, now I am applying VGS positive and VDS also positive. Now see, okay na? So this is the gate, this is the source na. Now I am applying VGS is positive. So here I have positive charge, I have negative charge. Now see, these electrons having the negative charge and this is the positive charge. So these electrons get attracted and the current will flow like this. When VGS is positive, VDS is positive. So these electrons combined here flowing to like this and current flowing. Okay na? So IDS is also increasing. So now my characteristics are like this. This is the 0 and this is the ID, this is the VDS, now like this. So here VGS equal to 1 volt, VGS equal to 2 volts, VGS equal to 3 volts. Okay na? So VDS, ID and VGS. Okay na? This is the working principle of D-MOSFET. Okay, we will go to the E-MOSFET. Enhance. Okay. Something. Next one, enhancement MOSFET. So now see, the major difference between enhancement and D-MOSFET is channel is absent here. Here channel is absent. So when, now see, VGS equal to 0, VDS is positive, VGS equal to 0 and VDS is positive. This is the positive and this is the negative. This is the P substrate. Now see, when VGS equal to 0, VDS is positive, VDS become short circuited and VDS is positive. This positive charge is accumulated on the drain terminal, but here no electrons are there because no channel in enhancement MOSFET, so no electrons will be there. So no electrons will be there. This is the major difference between enhancement MOSFET and D-MOSFET. In D-MOSFET we have N channel, in enhancement MOS we don't have any channel. So even VDS is positive, drain current becomes 0 because no path for the flow of current. Okay na? Now see, now I am applying some VGS positive and VDS positive. Now see, my condition is VGS positive and VDS is positive. So whenever the VDS is positive, the positive charge accumulated on the drain terminal. Now gate is positive. It means on the gate terminal I have some positive charge. We have P substrate na. In this P substrate there are some minority carriers are there. In P substrate there are some minority carriers are there. In P substrate that minority carriers are electrons. We know that electrons having the negative charge, so this negative charge will get attracted by this positive charge. Now current flowing through the gate to source terminal. So now the channel is formed, nothing but depletion layer is formed between the doping region of N regions. So ID will increase. Okay na? This is the construction of enhancement MOSFET. Now see the diagram of, when VGS, even VDS is positive, VGS equal to 0. When VGS positive, VDS positive, ID will increase. Nothing but this is the input and output characteristics of enhancement MOSFET. This voltage is called threshold voltage. This voltage is called threshold voltage. So After threshold voltage only, current will pass through the, drain to source. So this is the output characteristics of ID and VDS. This voltage is called threshold voltage. So what is threshold voltage? It is the minimum voltage of drain to source to make ID flowing through the circuit. It's like PN diode voltage is there na, potential barrier, nothing but. So in PN diode we have 0.7 volts, after that 0.7 volts only diode will start conducting. This is the 0.7 volts, nothing but potential barrier. Like that only we have threshold voltage in enhancement MOSFET. After the threshold voltage only, that MOSFET starts conducting. So this is called enhancement MOSFET, and we have only one topic is left, that is the difference between MOSFET and FET. This is the very, very, very important question in your exams. Difference between MOSFET, difference between FET and MOSFET. This is the very, very, very important. So FET is high input impedance. This is also high input impedance. The order of high input impedance is around 10 power 8 ohm. This have range of 10 power 8 to 10 power 15 ohm. Okay na? So the second one is this. So FET is a current controlled device. FET is a current controlled device. So MOSFET is a current controlled device. This is also current controlled device. Here RD is very high. I already told what is RD. RD is nothing but drain resistance. So here RD is low. These are having high gate current. This is the low gate current. Okay na? Difficult to fabricate, easy to fabricate. Okay? One more point is there, 4, 5. This is the very, very important point. Less speed of operation. Less speed of operation compared to MOSFET. High speed of operation. Okay na? So this 6 points is enough for your exam. This is the most important question. What is the difference between FET and MOSFET? Okay? So with this I am closing this session. Okay? Thank you all.